So I had asked you guys, just a quick refresher of what you should have been doing. You were working on page 38 in your packet. We crossed off Oklahoma City. I don't know why I even included it. Like it was extra information. We crossed off A down here, and then I just pointed out to you that instead of B, C, and D, it should have been Denver would have been B, Tampa would have been A, and Chicago, I'm sorry, B, C, D. I can't speak. So Oklahoma City would have been A, Denver would have been B, C, and then D, but we got rid of A. So we did the arrival time for Denver for the P and S waves together. So that was 2:38 for the P, and we decided it was 2:41:50 for the S. Again, you could have estimated that slightly different, and it's okay if you had a slightly different. I'd say if you're within 5 to 10 of mine for this activity, that would have been good. Then you had to subtract. Now, I walked around and I didn't see a lot of math being written down. And maybe for this one, it would have been okay because this math was fairly simple. But when you don't write your math down, people tend to make a silly math mistake. So just to do this one real quick, always remember the bigger numbers on top. 50 minus 0 is 50. 41 minus 38, hopefully you know that is 3. Now, but last class, this was a huge problem. 41 minus 38 was a big problem. And guys, please don't make 41 minus 38 be a problem. Do the math in a calculator. I promise I will not tell your first and second grade teacher that you can't subtract really well in your head. You don't need to, because I had a bunch of people subtract this wrong and then go ahead and do all the perfect earth science. And me as an earth science teacher, I only care about the earth science part. But if you did the math wrong here and put down the wrong number here because you subtracted 41 minus 38 wrong, it really stinks that I have to mark it all wrong, even though you did the earth science right. So I know that you know most of the math in your head, but could you just use a calculator just in case? If you don't have them, I always got one over there above the fire blanket. All right, I had a bunch of people. Once you had that number, you kind of blacked out of what you were supposed to do, even though you've been doing it for weeks now. Anytime you see something about difference in arrival time, scrap paper. You grab your scrap paper, you mark off that difference. So 0 and 350. You slide it up till you find where it fits pretty good. And I had mine fitting perfectly. Oops, I originally had mine at 2,400. It's looking like this set of marks would have been better at 2,500. Either one's good with me. So that's why you get that little bit of wiggle room, because both my answers, like this time it's working out perfectly at 2,500. The last time it worked out perfectly at 2,400. So you do get that wiggle room. When you did this math here, or first with Tampa, what'd you get for Tampa's P wave arrival? What'd you get, Allison? Yours was correct. Wait, yes, I'm sorry, I was looking at the wrong city. I'm like, that's not right, but that was me, not you. 234.30. And Brooklyn, what'd you get for the S wave? I agree. This is the one people did math in their head and got it wrong. So let me just show you what happens when you write it out. 236, 234.30. I had a bunch of people tell me that the difference here was 2 minutes and 30 seconds. That wasn't right, because you have to borrow. When you do 0 minus 30, you had to borrow, make that 35. This became 60 because you borrowed 60 seconds. 60 minus 30 is 30, and now it's 35 minus 34. So that was a minute 30. And when I did a minute 30 on the reference table, well, actually, what'd you guys get? What'd you get, Phoenix, when you did 130 on the reference table? That's exactly what I got. Perfect. Chicago, this one was a little bit, hopefully you saw that the P and the S waves each hit a little bit before. So like this one was a little before 36 and that was a little before 38. I went with 235.55 and 237.55. I bet a lot of you didn't use those exact numbers though. Would you use, Phoenix? 50 for both of them? Yeah, that's perfect. Anybody else use another number? And for the S wave? Okay, perfect. So, and I do kind of agree. It looks like this one's a little bit farther away. So either way, you're good. And then so so your subtracting might be slightly different than mine. I know yours will be. You got 2 minutes even, right?
Yeah.
Yeah. So if your subtracting was slightly different because you use slightly numbers, again, as long as you're really close to my answer, you're good. And Remy, what'd you get when you slid it? Marked off the 0, marked off the 2. You got 1,000 even. I got 1,001. Did you have 2 as your answer here? Okay. So I had 1,100, but your 1,000's perfect. Guys, if you're just off by 100, consider yourself correct. It's not even being wrong. 200, if one of them's off by 200, it's okay.
Yeah.
If every single one of yours is off by 200 from mine, then one of us is doing something sketchy.
It's just like
Yeah. Okay.
yeah.
Perfect. So, do you have those numbers? What does that mean what does it mean that the epicenter is 2,400 kilometers from Denver? We talked about this on Wednesday. What? I think you know what you mean, and I think I know what you mean. I think it was right, but the words did not match, I don't think. What's it mean? What's an epicenter, first of all? Let's go back to the first day we worked in this packet. It's where the earthquake started. It's where the plate. Oh, that was a big mistake. I have a cut on my hand, so I shouldn't do that. But it's where the plates hit each other. It's where the earthquake happened. So saying that the epicenter is 2,400 miles from Denver means that if you're standing in Denver, the earthquake is 2,400 kilometers from you. But what did we say is the problem with just knowing that? Do we know where the earthquake is? Right. We don't know exactly where it is because it could be 2,400 this way, or this way, or this way, or this way, or this way. And we started talking about on Wednesday, this is where we need to start drawing circles. So we practiced using these compasses. If you didn't grab one, come up and get one. Thanks. First things first, you got to check your compass because they're junk. First of all, does it swing freely from the bullseye like this? If it doesn't, it means your bullseye's in there wrong. Second, okay, if it's working, you got it. So it can do this, okay. So as long as it can swing freely, you're good. Can you tighten down and or loosen the little blue knob so this part wiggles back and forth? For some reason, these are righty-tighty and righty, oh my gosh, tried to be funny, but it works both ways. Righty-tighty and tighty-lefty. I don't know why. Lefty-tighty, thanks. You knew somebody could handle it. So if it's not working one way, try it going the other way. I don't know why they're like that. They just are. So I think we talked about this on Wednesday, but I'm not sure. There are rulers on here. So that way we could make a circle that's a certain number of inches or a certain number of centimeters. But we don't care about inches or centimeters when we're talking about earthquakes. Our numbers were in kilometers. These numbers are 2,400 kilometers. So we don't care. You're going to completely ignore the rulers on this. We only care about the scale down here. This, what? Yeah, it's on the next page. So if you haven't found the map, it's on the next page. So we need to open our compass by using the scale. Again, not the ruler part on the compass. We're going to use the scale. So first thing first, where is 2,400 on this scale? So, yep, yeah, you guys got it. One thing I want to point out is not all scales are created equally. It's always important to double check the scale that you're looking at. This one, the lines go up by 100, 0, 100, 200, 300, 400, 500, 600, 700, 8, 9, 1000. Sometimes they'll go up by 200. Sometimes they'll go up by 50. So before you ever start measuring, double check the scale. Just like on a graph, just like on these things. The first thing I always want you to do is look at the scale. What I do is I go ahead and I mark 2,400 just so I can see it and I don't have to think. You guys know I don't like thinking twice. So if I think once here, then I don't have to think about it again. Now the bullseye is the important part. Hopefully you notice that if the directly above the bullseye is this like 90-degree angle in your compass right here. What we're going to do with this little 90-degree angle is put that right lined up perfectly with the scale so that 90-degree angle is right on 0. Then you can take your little slidey part of the compass and we're going to point one of the holes at the 2,400 mark. So see how it helps that I marked it off now because I don't have to look under the compass for the 2,400. And then once you're positive you're at 2,400, here's where a third hand might come in handy, but you only have 2 hands. So figure out how to tighten it down without moving anything. So I kind of hold the compass and the slidey part with 2 different fingers and tighten it down. Now you may have noticed there's 2 different holes. I don't care which hole you use, but I used the outside hole. So I have to remember that this is the hole that matters right now. If you use the inside hole, fine, it works. Just remember you use the inside hole. So once you have it tightened down at your 2,400, we're going to take the bullseye, and you should notice on the bullseye, there's an X with a circle in the center of the X. You're going to put that directly over the city you want to draw the circle around. So we're putting that directly above Denver. And then here's where you got to practice your circle drawing. So you hold down the bullseye over Denver. Stick your pen in whichever hole you measured with. So I used the outside. I don't know what you guys used, but use whichever one you measured with. And go ahead and drag it around and draw your circle. You will have trouble when you get up to the staple. So you might have to stop going in that direction and go back. Hopefully you didn't move like I just did. And again, I'm stuck at the staple, so I'm going to try my best. And I might just have to sketch that last part in. You are also more than welcome to go ahead and rip that last page off if that makes your life a little bit easier. Now we're going to go ahead and do this. So first of all, does your Denver circle look similar to mine? Did it go through near the P in Tampa, just over past the S in San Francisco? If you didn't, you might have used the wrong hole. So if it doesn't look like mine, you might have measured with the outside and drew a circle with the inside. Slightly is okay, but if, oh yeah, so yours is going to be slightly bigger. Yep. All right, now we got to do the same thing for the other 2 cities. So this was just for Denver. Now go back and open your compass to whatever distance you had for Tampa. Put the bullseye over Tampa and draw the circle with the new distance. Then do the same thing for Chicago. but when they do all intersect, ignore the whole time. Yeah, you know where the epicenter is? You got it. Yeah. Okay, a couple more minutes. I'm gonna finish up my circles here. And then we'll go through them. They did at one point. I would assume that at this point in history, they have machines that do this for them. But this is then how that computer would do it. It's the same concept, but I'm sure there is a computer program that can just bam, do it all for you. One of the reasons, I think I've said this before, that I don't like teaching this concept is because scientists don't do this anymore either.
You should give us.
Next year, I won't have to teach it, so. Yeah, because there's the new standards have eliminated this part of it. They talk more about the practical parts of earthquakes, like how to make good buildings or what kind of codes might need to be in place or where you might need built-in earthquake codes versus where you don't need them and things like that. So more like practical things for everyday people. All right, so hopefully yours looks something like mine. This one got a little messy on me. I want to talk about where the epicenter is. Now, normally there would be directions. I have no idea why I did not include directions for this activity, but normally it would say, mark the location of the epicenter. Now, some of yours came out beautifully, similar to this guy right here. Where's the epicenter? Mine, this one works too. Where can we say the epicenter is? Yeah, Phoenix, go ahead. Where all the circles meet. So keeping in mind where all the circles meet would answer yes to being 2,400 kilometers from Denver, 800 from Tampa, and 1,100 from Chicago. Where those all touch is the only place that says yes to all three of those things. So in this case, this one that I did, they perfectly touched right here. But remember how it's okay to be off by 100 kilometers? Remember how I even told Drake it was okay that he was off by 200? This is where being off might mess with you a little bit. Because if you were off by 200, that's a distance from here to here. That's a pretty hefty distance. So your circles might not match up perfectly. On mine, like this one here, they were pretty darn close, but they didn't match up perfectly. Does anybody else have one that didn't match up perfect? Can I borrow yours then? Yes, this is a little bit better example than mine up here. So Trent did his and they didn't match up perfect. Does that mean he did it wrong? No. In fact, when we were just talking about it, I used 2,400 for Denver. He used 2,500. So it's a little bit off. If each number was off by 100, that might mean your circles don't intersect. So in this case, we got to look to see where they're all three trying to touch. So what I like to do is kind of go through and see, well, where are they all touching? So I start here. Okay, there's two touching there. Where's the third circle though? Way up there. Okay, so I keep that in mind. Here's two over here. Where's the third circle? Way over here. Not super close. There's two touching up here. Where's the third circle? Way down there. But when I get here, here, and here, here's one. Where's the third circle? Okay, it's a little bit closer. It's just down there. If I'm over here, where's the third circle? Oh, it's right there. Same here. So right here in this general vicinity is where all three circles are trying to touch. So we're going to go ahead in this case say, okay, well, the epicenter's in that area. So you do have to see where they're all the closest to all three touching. So it's always going to be in that triangle shape. Now, Sam was talking about, well, here's another triangle shape. He's not wrong. There is a triangle shape there, but there was a better triangle shape up here to put the X in up here. So it's okay. Like this, as long as he had put his X in this general vicinity here, this is 100, even though they aren't perfectly touching. So as long as you're still able to decide, okay, this is where they're supposed to be touching, you're good. So walking around, you guys all looked pretty good. So it's not looking like we're gonna get too much time to go over the homework from yesterday. So I think that's where we'll start on Monday. Actually, you know what? Do you still have it out? Let's go over to page 1 because that one, yeah, get it out. Page 1 was not that complicated. Walking around, I think almost all of you had done page 1. So we've got these diagrams that represent different type of plate boundaries. The arrows show the direction of the plate movement. So I wanted you to complete this chart. So it was really just review of what we did at the beginning of this chapter. We're going to have a test around Wednesday next week. This will be on that test using page 5 of your reference table. So you can see here, because the arrows are pointing together, that's a convergent plate boundary. I did label it as an ocean and a continent plate converging. You didn't need to do that. What gets formed here, you should know that there's trenches, mountain ranges, and volcanoes that form there. I did not put an example because I would have accepted literally any example of a convergent plate boundary. Oops, wrong one. So I would have taken here, India and Australia hitting the Pacific plate near the Tonga Trench or the Aleutian Trench, or here with India hitting Asia. I would have taken any of those. The next one down, this guy where there are two plates sliding past each other, that's a transform, and they create faults. I did include the most famous one, which is the San Andreas fault, but you could have taken, there's a couple different options. All right, we're on to this guy right here where the plates are spreading apart. That's divergent. That makes a mid-ocean ridge. I picked the mid-Atlantic ridge, but there's lots of other ridges. So as long as you talked about a place on the reference table where they were spreading apart. 2 and 3 here were a little bit trickier, a little bit more remembering. It says, what layer of the earth has convection currents that cause the plates to move? Remember, the lithosphere is floating on the asthenosphere. And then this last one was just kind of a quick review. Whose family did I use for this? Phoenix's family. So this was talking about the magnetic reversal, how it goes from being normal at the ridge to being reversed back to normal. All right, so that looks about as far as we can get going over this. We'll go over the rest on Monday. Guys, there's no homework this weekend. Here's what I want to see from you guys on Monday. I get that there's a Bills game. I get that it's late, but no matter the outcome, please do not let a group of men determine your happiness on Monday, okay? So no matter what happens, do not let those men, the football team, control your lives, okay? The end. Have a good weekend.